All right, students, welcome to the very last part of this. This is a really long section, but it kind of goes through everything you need to know about the graphs of the sines and the cosine. So just starting off here, what we're going to do is everything backwards. So we're given a graph. We want to be able to find its equation. And the equations have these forms. Okay, there's this and there's this. I think the second one is supposed to obviously be a cosine, I think. Okay, so you might want to scratch that out and make that a cosine. All right, so just to review, we know that A gives the amplitude. We know that the number B gives the period based on this formula. C is the phase shift. Plus C is left, minus C is right. And then D gives whether the graph goes up or down. All right, so what we're going to do is we look at this example down here. The first thing I want to start with primarily is look at the midline. So if you look at this, the maximum y value is equal to 1, and the minimum y value is equal to 0 on this problem. So the midline is just halfway between those. So your midline will go through like this, and then that will give us the equation y equals 0. The benefit of the midline really is when you're looking at this, you can tell how the function translated up or down. That's kind of the key. All right. Next thing we'll look at is the period. So the period would be just kind of count out your 5 key points. I'm going to just sort of trace this out. It doesn't really matter. I'm going to start from here. Generally, I like to just start at 0 right there. So we have a point there. You would have another. What I'm doing is just tracing out my 5 key points. So your period would be, on this particular problem, from there to there. So that means the period is going to be 2 pi. Okay, so we got that. All right, now next thing is the amplitude. So the amplitude, you look this way. You look at up and down. So remember, the amplitude is half the distance from the max to the min. So the amplitude is going to be 1/2 the maximum y, which is 1, and the minimum y, which is 0. So that'll be 1/2 of 1, so that's equal to 1/2. Okay, so that amplitude on this particular problem is 1/2, all right? So we got that now. And then what we want to do is we want to look and see if there's a phase shift. Now what we're doing on this is we're going to model this. My directions to the problem say model this with a sine. So we're going to use a sine wave. You could use a cosine on this same problem too. And we can kind of look at that in just a minute, how you might do that with a cosine as well. So the idea is, let's do a sine on this. Well, the sine, you're used to the sine starting at this point right here. Okay, that's kind of like your point number 1, and then this would be your second point, and then your third point, your fourth point, and then you would have this midpoint being your 5th of the key points. Okay, so one thing you see on this then is clearly this thing has been phase shifted, and it's been moved up. So that midpoint is kind of where the sine starts, so that has been phase shifted to the right by pi over 2. And I know pi over 2 just because you can tell that's halfway between 0 and pi like that. All right. The other thing is this thing has moved up by 0.5. All right. So again, what you got to look at on this, remember this midpoint, you're used to that midpoint being at the point 0, 0. The sine starts at 0, 0. So it's phase shifted and it's moved up. So we've got all the key components on this, and now we need to just start putting this together basically then, okay? All right, so what we want to do is let's just kind of write down everything we have on here. So we have the amplitude is 1/2, so that's important. Now we don't know B, but we do know the period. So what you do is you use the formula, the period is equal to 2 pi over B. And the period's 2 pi, so we're going to solve this equation to find what B is then. Okay, so you can cross multiply there. So this one's easy enough to do in your head. If you cross multiply on this, you would have basically just this. You would have 2 pi b equals 2 pi. You could divide both sides by 2 pi, and you would get b is equal to 1. That's anytime the period is 2 pi, b is going to be 1. Okay, so we have that. All right, the phase shift is what c is, so that's to the right, pi over 2. So if it's right pi over 2, you would have minus pi over 2. And then we figured out that it's going up 0.5, so that's what d is then. All right. So again, the key thing if you're modeling with a sine, and I can't emphasize this enough, is you got to look at this point right there. Okay, that will tell you how it's phase shifted and whether it's moved up or down, because you expect that point to start there. Okay, now what we do is we're now ready to get our answer, okay, to this. So we just look at the basic format here, and this basic format goes like this. I'm just going to do this to the side. We have y equals a sine, bracket b, parenthesis, x minus c, plus d. All right, so we just now plug everything in. So let's see, the amplitude was 1/2. So that goes there. B we figured out was 1. C was the phase shift, so that's pi over 2. And then D was up 0.5. Putting that all together, you should have the answer to your problem. So we'll have for an answer y equals 1/2 sine of 1. And then x minus pi over 2, and then plus 0.5. Now you can obviously leave that 1 off of there and just write this as sine of x minus pi over 2. All right, and that's the way I'm going to write the final answer is like that. So I'll write this then as y equals 1/2 sine x minus pi over 2, and then plus 0.5. All right. All right, so that'll take care of the answer to that problem then. All right, so that's how you do that. Okay, it's really just a matter of finding A, B, C, and D by looking at the graph. Okay, now you could also model that with a cosine, and a cosine would be a little bit different on that. I'm not going to do that on this problem because I'm going to do the next one with a cosine, and you can see the difference between the two. Okay, so that's how that goes. Now again, you could check this problem. And you know, math is great because you can check everything you do. So let me just show you kind of this on a couple of problems. What you can do is just, you know, pick an x value and plug it in. Let's just keep it simple and let's plug in like, let's say pi over 2. Or, yeah, let's do pi over 2 because that's easy. So let's just do x equals pi over 2. And then I'm going to just plug into my answer. So I'd have y equals 1/2 sine pi over 2 minus pi over 2 plus 0.5. I picked 0.5 pi over 2 because it makes this the sine of 0. So that would give you 1/2 sine of 0 plus 0.5. The sine of 0 is 0. So you'd have 1/2 times 0 plus 0.5. So that gives 0.5. The reason it's right is because if you look at that point, so if you look at that blue point right here that I got highlighted, it has a y value of 0.5, so it checks. So you can tell, I mean, one point doesn't prove it, but probably if you do at least 2 points, then you can tell that you've done that right. Okay? All right, so hopefully that'll go well for you as you're doing these problems. Okay, so let's move to the next one. And the next one we have this given graph, and this time we're going to model this one, I decided with a cosine. Okay, what in the world happened here? Okay, there we go. All right, so we're going to model this one with a cosine. And we're going to just kind of look at all the different parts that we've been looking at. A good starting point is usually the midline. The midline, on this one you have a maximum y equaling 3, so that's your max. Your min is at 1. Okay, so the midline is just going to go straight through that halfway point, so that's going to be y equals 2. Okay, and that will help you to figure out, it helps mostly on a sine. On a cosine, that'll kind of help you figure out your amplitude also. Okay, so the period, just kind of count out 5 key points. And what I usually like to do on this is, just start at 0, 0. So I'm just going to kind of look at, that's my first point, that's my second point, that's my third point, that's my fourth point, and then that's my fifth point like there. So the period's 2 pi. So the period is always looking at this part right here on the x-axis, so that's 2 pi. Okay, the amplitude on this, we have the formula for amplitude, which is 1/2 the max minus the min. I put that in absolute value because you want to end up with a positive number regardless of how you subtract those things. You can do this in your head also. So the max is 3, the min is 1, so you end up getting half of 2, so that's equal to 1. See, the other thing you can do on this is this. The distance from the midline to the maximum is the amplitude. Okay, so you can just do that in your head. So that amplitude is equal to 1. Okay, now the next thing is a phase shift. So if you're modeling with a cosine, the thing about a cosine is you're used to the cosine cycling through starting at that 0.01. So the key thing is to look at this maximum and figure out how far that thing has phase shifted and how high up it has gone on that then. Okay, so we'll kind of take a look at that then. So that thing clearly has phase shifted over again, just like the last example. That has moved to the right, pi over 2 like that. Okay, so we got that. So what we're going to end up doing on that then is you want to think about how far that thing moved from the midline. And the midline kind of helps you figure out what your how high up this thing has shifted up. Okay, so we'll look at that and then we'll start putting this all together. Okay, now finishing this up, as far as the up translation, we also on this problem are moving up. So this is what you do on a cosine. Usually on a sine, I tell students to look at the midline and figure out how far up it has gone, because the sine starts at a 0.00. It starts at that midpoint. Well, a cosine it goes like this. This point right here would have started there, see. Okay, if it's a basic cosine, it starts up 1. So that point right there has moved up 2 units from that point. So that means we would have that this thing has moved up 2 on here. Okay, then we're ready to put everything together. So that point right there moved up like that. We had the same amplitude that we would have on a basic cosine. Right, so now we're ready to put this all together. So again, what we pieced together on this problem was the amplitude was 1, so that means A is 1. The period is 2 pi, so again we solve this formula like we did in the last problem. We say the period, we just write down the period formula. Okay, so we'd have period equals 2 pi over b. You can do this in your head too if you want to. That's 2 pi, which is the period, is 2 pi over 1. So b is 1. So you can do that in your head, or you can solve that proportion like I did in the last example. C is the phase shift. Okay, we figured out that this phase shifted to the right, pi over 2 on this. Okay, so we have that. And then you would end up having minus in your formula. And then we went up 2 like that. Okay, so now we're ready to put this all together. So I'll do this at the side. So the general form is y equals a cosine b x minus c plus d. So now we're ready essentially just to plug everything in. So the amplitude is 1, b was 1, the phase shift was pi over 2, and we have a minus because it went to the right, and then we went up 2. Okay, so the final answer on this would be, you could just write this as y equals, and I'm going to write it like this. You don't have to put the 1s there, but it would technically be 1 cosine 1 minus x minus pi over 2 plus 2. So you can write this just as cosine of x minus pi over 2 plus 2. So if you kind of look at this point right here that I'm, highlighting there, that point just went over pi over 2, then it went up 2. All right, and that's it. So if you wanted to do a check, you can check any point you want to on this. So I'm going to do, this time I'm going to do 0 just for something different. I'm going to check x equals 0. So what I'd have is y equals cosine of 0 minus pi over 2 plus 2. That would be cosine of negative pi over 2. Why does it keep doing that? Okay, cosine of 0 minus pi over 2 plus 2. Okay, if you look at a unit circle at negative pi over 2, the cosine is 0 plus 2 equals 2. Okay, look at the point. When x is 0, we got 2. Okay, and all the points should check, so this should be a valid answer to that problem. Okay? All right. Okay, so get that written down if you need to. Otherwise, I'm going to have you move on to the next page and then try, let's see, 2 problems. I'll have you try 2 problems on the next page and see what you can come up with on these then. Okay, so the first one I want you to do with a cosine, the second one with a sine. Okay, so good luck, and go ahead and pause. Check your answer. It's a good idea to pick a point and check it before you check my solution. Okay, good luck. Okay, so I'll go ahead and let you check, and I'll kind of run through what I'm doing here. If you got them okay, then you can move on. In looking at this graph on the first problem I had you do, to start with, I kind of look at these key things. Okay, the midline, I always look at the max and min. The max is -1. The min's -5, so that'll help you figure out the amplitude. The midline goes halfway between, so that would be y equals -3. The period, now you can start counting wherever you want to. Since I was doing a cosine, I decided, well, I know the cosine starts at a high point, so cosine starts there, so I'm just going 1, 2, 3, 4, 5 key points. So that period would go from here to here. So 5 minus 1 is 4, so the period should be 4. Okay. The amplitude, you can do the formula, 1/2 the max minus the min, so that would end up being 2 if you do that. You can also just count from the midline to the maximum or the midline to the min. Doesn't really matter, so that amplitude turns out to be 2. Okay, the phase shift, and on a cosine, I look at it like this. A cosine starts there if it's a basic cosine, but that high point moved there. So that phase shifted to the right 1 unit. Okay, the phase shift can be more than one thing too. I mean, you could also say, okay, this thing moved to the left 3. Okay, if you wanted to, but it's just as easy on this to just make that go to the right 1. So we got that, and then the down part. Okay, the down part can be kind of tricky on this for students a lot of times. So what's happening on this is the amplitude's 2. So what happens is with this, what happens is you end up kind of looking at where that midline kind of went. So if you had an x-intercept, well, that would move down 3 right there. Okay, from the x-axis to your midline is going to usually tell you where you're going down. So that's going to be down 3 like that. Okay, not down 2. I think some of you may have got down 2 on that, but that thing right there has moved all the way down like that, down 3 like that. And I'll show you how that checks out here in just a minute. So here's another way. The up-down sometimes is real confusing for students. Here's another way to look at this. Since the amplitude is 2, okay, this point right here, if the amplitude's 2, then the maximum on the cosine would have went there. So that point right there would have went right 1 and down 3 to get to that maximum there. That's another way to look at it is look at the amplitude. Okay, before you have the -3 down, then you would have a maximum of 2 on a cosine. So that thing has moved over and down. Okay, so I got everything I need now. And then the other thing that you want to do to kind of wrap this up is the period. The period's 4, so use the formula period is 2 pi over b. So we'd have 4 is 2 pi over b. You can cross multiply to get 4b equals 2 pi. Divide by 4, you get pi over 2. Okay? And b can have a pi in it. So again, using this formula, the amplitude is 2, b is pi over 2, c was to the right 1, d was down 3. So if you plug everything in, you should get this point like this. Now seriously guys, one thing you want to try to do is learn how to check in your head. And just pick a real easy point. I pick 1 because 1 minus 1 is 0. So if you checked at x equals 1, you would have 2 cosine pi over 2, 1 minus 1, minus 3. So that would be 2 cosine of 0 minus 3. Cosine of 0 is 1, so 2 minus 3 is negative 1. And look at that point. It's got a y value of negative 1. So that point checks, and then I recommend you probably plug in a 2 and see if that works, because if 2 points work, you're probably in good shape. Okay? All right. I find the up-down thing is usually the hardest part for students. All right, so let's see. Let's look at the next one then. Okay, so I went ahead and gave 2 answers on this because your phase shift could be done either way. So first of all, just looking at this, you have a max of 2, a minimum of negative 4. That's a good starting place is to write those things down. The midline would go through these midpoints. So the midline would be y equals negative 1. That's just halfway in between 2 and negative 4. And then the period, it doesn't really matter where you start counting. You can start here, you can start here. I think I just started here. So I did 1, 2, 3, 4, 5 key points. So from 0 to pi would be that cycle. So therefore that period would be pi. Okay, the amplitude, you can always look at the distance from the midline to the maximum. So if you look right here, that's 1, 2, 3. Or you can use the formula, just doing 1/2 the max minus the min. Crunch that out, you get 3. Okay. The phase shift, now see, we're modeling this with a sine. So I kind of look at it this way. Okay, the sine starts at a point like this. So I'm going to just kind of show you this. So that's where you would expect the sine to go. And then the sine would go to its max and then go like that. So what's happening is you can look at this one of 2 ways. That point has either phase shifted to the left 1, which is, or not 1, pi over 4. Halfway between pi over 2 is pi over 4. So it's gone left pi over 4. Or you can think of that point phase shifting all the way over here. Because remember, a sine starts here, hits the height, then goes through points like that. So you can think of that point as either phase shifting to there, or you can think of it phase shifting to there. Okay? So I kind of put it either as right 3 pi over 4 or left pi over 4, like that. And I just went ahead and did it both ways. All right? And then the down part goes like this. Well, again, if you just kind of look at this point right here, all right, that midline, this point on the sine has moved down to get to this midline right here. So it's just down 1 is how that point's gone. All right. And then what we have from here is, and you can kind of think of, an x-intercept moving down 1 on an original sine wave. And then we find what b is. So we use the formula periods 2 pi over b. Okay, we solve this equation, we get b equals 2. So you can look at the details on that. So what I have basically is I have a is 3, b is 2. C can either be phase shifted to the left pi over 4 or to the right, and then down 3. So I just gave you 2 answers. One of them, if you plug A, B, C, and D in, so this would be the phase shift to the left. You would have 3 sine 2x plus pi over 4 minus 1. And then if you did the phase shift to the right, you would have this answer right there. Okay? And again, try to check in your head. It really, with practice, is not that hard. What I would do is just check negative pi over 4 because it's so easy. Okay, so if you use x equals negative pi over 4, then you would get y equals 3 sine 2 negative pi over 4 plus pi over 4 minus 1. Okay, and by doing that, this is pretty easy. Once you learn the unit circle, it's pretty easy to process in your head. That would be 3 sine of 0 minus 1, because that whole thing would become 0. So that's 3 times 0 minus 1, so that's negative 1. So notice when x is negative pi over 4, then you're at negative 1. So that checks that point that I'm looking at is right there as my checkpoint. Okay, so that's it. I'm going to go to the next page. Pause if you need to process and think about this a little bit. Those would be 2 acceptable answers. Okay, this next one, I'm going to do just one more example myself on here. With this, just something a little bit different on here. I think I've gone over this enough, but I want to just do a couple of more of these things here. Okay, so let's take a look at this one, and then this one we're going to model with a sine. So the way I like to look at a sine is kind of like this. I like to identify my key points, and the midpoint, first thing we want to do is kind of look at the midline. So again, on this one, the y max is 4. The y min is negative 4. So that midline is halfway in the middle. So this time the midline is y equals 0. So that's going to mean that we don't have any vertical translation. So that's y equals 0. Okay. Now the period, you just got to kind of decide where you want to start. A lot of times what I do on a sine wave is I try to get students to identify the key points. And the key points on this doesn't really matter. You could start even here if you wanted to, or even there. A sine wave starts at 0, 0. So it's kind of good to find that point right there. So I'm going to kind of look at this like this then. Okay, I'm going to start with, there's a midpoint, there's a max, there's a min, there's another midpoint, and then there's that. Okay, you just find 5 key points to figure that cycle out, and the period would be, one way to look at it would be from there to there. Okay, and if you look at that, it looks like, let's see on here, this is negative 4, that looks like negative 8. So when we're doing that period, we're going to go from negative 8 all the way to, and it looks like that's 4, so it looks like that would be half of that, so that would be 2. So it looks like we're going from negative 8 to 2, and that distance, if you do negative 8 minus 2, the distance on the number line between negative 8 and 2 is 10 units. Okay, so that period looks like it's going to be 10. You could do this another way too. I mean, if you want to, you could start like this this point. It doesn't really matter where you start. You could start here and then move from that point to the end point like that. Just try to find a starting and an end point when you're doing that then. Okay, and then the amplitude. Now, the easiest way to me to get the amplitude is just look at the midline and the maximum, or you can use that formula. So your amplitude is on this is going to be 4, because it's half the distance from the max to the min. Or again, if you want to, you can do amp is 1/2 the max, which is 4, minus the min. So that's 1/2 of 8, so that's equal to 4. So you can do that either way. All right, so we got the period, from crest to crest is the way I look at that. And then we have that. Okay, the phase shift and the vertical translation are always the harder parts for students. So I kind of look at it like this. A sine starts at 0, 0. So this is the point that got phase shifted, is this point right here. Okay. Another way to look at this is, if it's easier for you, will be that maximum. Usually on a sine, I try to look at that point right there then. All right. So what you would end up doing if the period's 10, this thing, if you want to, you can say that it phase shifted to the left, and that looks like that would be to the left 1 is what I'm seeing on that. Okay. And if you kind of look at this, the other place where you would have a midpoint is right in here. So you could also kind of think of that being a starting point there. So I think the best way to do that is just left 1. Okay, it's not halfway in the middle on that. I was trying to think another way to look at this. If the period is 10, so if your period is 10, half of that period would be 5. So another way you could kind of look at that is if you go, starting here, if you go half of that period from here to here would be 5, and then that would just be over 1 unit like that. So you're going to the left 1, right? And then now what we're going to do is the down part, you're up, down, 0. You don't have a vertical translation because of that. Okay, now we're ready to, the midline 0. Okay, so what we have is the amplitude is 4, so that's that. Okay, we're going to use the formula period equals 2 pi over b now. The period is 10, so we want to solve this equation. So that would give 10b equals 2 pi. Dividing by 10, you're going to get b is equal to pi over 5. Okay, so that'll take care of that then. And then c is the phase shift, so we're going left 1. So we're going to have a left 1 phase shift. And then d is 0. Okay, then we're ready to essentially just put this whole thing together. Okay. Hardest thing to me on this one, let's see, is that phase shift and how that's only 1, it's not 2. You can tell visually that's right. Okay, so now the formula is y equals a sine bx minus c, and then plus d. All right, so what we're going to have is the amplitude's 4, b is pi over 5, c is to the left 1, so that means you're going to have a plus there, and then d is 0. Okay, so my final answer on this problem is going to be this then. I'm going to get y equals 4 sine pi over 5 x minus 1, and you don't need the plus d. So that's it. And then you can check a couple of points on there and see if you're right. What I would recommend you check on this, because it's simple, is to check x equals 1. And try to do this in your head, by the way. So if x is 1, this would end up being sine of 0. So the sine of 0 is 0. 0 times 4 is 0. So if x is 1, or x is 1 on that, you should get 0. Now, hold on, I did something wrong on that. I just caught that, and that's one of the benefits of checking, is you have a left 1, so that'd be plus 1. Okay, so that's got to be a plus 1. And then, and see, I caught my mistake by checking, which is good. I could lie and say I meant that, but I didn't. So use negative 1. Now try to do this in your head. If x is negative 1, that whole thing becomes sine of 0. Sine of 0, 0. 0 times 4 is 0. So, in other words, you have the point negative 1, 0, which is what we have. Okay, on that graph. And you could check some other points on there. You could go on and check other ones as well, and it should work out. Okay. All right, so let's see. One more here. Let's do the same problem. And I wanted to do the same problem here, but we want to model this with a cosine. Okay, so we're just kind of going back to the same diagram. And we already know most of this stuff then, so we're not going to have to repeat too much on here. So the midline is still y is 0. The period is still 10. Amplitude still 4. But it's the phase shift that's different if you're doing a cosine. So let me go up and zoom on this graph here and show you what I look at. Now what I like to do on a cosine is a cosine, remember a cosine starts at that point 0, 1. So this is the point that got translated. So I kind of think of this like this. This point here got phase shifted to the right 2. Now you can tell that's halfway in the middle there. That's not at 1, that's halfway in the middle. So that got phase shifted to the right 2. So on this problem, we're going to say that that got phase shifted to the right 2. Okay. Now the other thing is we don't have an up-down translation, so basically since the midline is on the x-axis anyway, then we don't have anything other than D is 0. Okay, so we don't have an up-down translation. Now to finish this problem up, what we're going to have is the amplitude's 4. B is just like the last problem. B was pi over 5. And then C this time is a phase shift of 2 to the right. So we'll use the cosine equation. So we'll have y equals a cosine B times x minus c, and then plus d. Okay, so plugging everything in, the amplitude's 4, B is pi over 5, C is right 2, so that's just going to put a 2 in there, and then D is 0. Okay, so a good answer to this problem would be y equals 4 cosine pi over 5 x minus 2, and then that should take care of it. Okay, now again what I'm going to do is just check. A good point to check that's real easy to do in your head is 2. So if you plugged in 2, you would have y equals 4 cosine pi over 5, 2 minus 2. That would be 4 cosine of 0. Cosine of 0 is 1, so you'd have 4. So if you go back and look at your graph, just see if you have the point 2, 4 on that graph. And then that would verify 1 point. So if you look at that, over 2 up 4, see that's a point. Okay? So don't forget to close these problems off with checking. At least do 1 point. And most of the time you can check these in your head, guys. So that's it. All right? So that will wrap us up on that. And hopefully that'll help you to do this last part of the section fine. So good luck. Let me know if you have any questions.